Ever stop to think about what's happening in that huge, hidden network of pipes running right under your feet? I mean, it's a whole world down there, and it's literally what keeps our cities running. Today, we're going to explore a really fascinating piece of engineering that lets us, believe it or not, predict the future of those pipes. All right, let's get into it.
So picture this, a huge water main breaks right under the busiest intersection in your city. You know what that used to mean, right? Months of traffic nightmares, constant noise, just digging up absolutely everything. So how do engineers fix this massive problem today without turning the whole city upside down?
Well, the answer is, it's kind of like magic. There's this amazing technology called cured and placed pipe, or you'll hear it called CIPP. What they do is, they basically feed a flexible, resin-soaked tube into the old broken pipe, and then they cure it. It hardens, creating a brand new, super strong pipe right inside the old one. The best part? No digging. At all.
Okay, so this all sounds great, but here's where the real engineering puzzle starts. That new pipeliner, it's perfect on day one. It's strong, it's seamless, but how can anyone be sure it's still going to be doing its job 50 years from now? I mean, think about the constant pressure from the soil, the water, all that traffic driving overhead.
Well, predicting that kind of long-term performance, we're talking decades into the future. It all comes down to understanding two really important properties of the material they use.
Okay, the first one is called flexural modulus. And yeah, I know, it sounds super technical, but it's really just a fancy term for stiffness. You know how when you try to bend a plastic ruler, it pushes back? That resistance, that's its modulus. For a pipe, this is what stops it from getting squished flat by all the dirt and weight on top of it.
All right, the second key property is flexural strength. And this one's different. This is all about the breaking point. So if you keep bending that ruler, eventually, snap, it breaks. The amount of force it took to get to that snap, right before it failed, that's its flexural strength.
So to put it really simply, stiffness, that's the modulus, is all about resisting bending. Strength is about resisting breaking. One's about how rigid it is, the other is about how much of a beating it can take before it fails completely. And if you're an engineer trying to design a pipe that lasts 50 years, you have to be an expert in both.
Okay, so if the material is stiff enough and strong enough on day one, what's the big deal? Well, there's this slow and visible enemy that engineers have to fight. It's kind of the villain of our story, and it's called creep.
And creep happens to pretty much everything. The classic example, a bookshelf. You load it up with heavy books, and it looks fine, but come back a year later, and you'll probably see it's starting to sag a little in the middle. The wood didn't break, right? But under that constant pressure, it slowly deformed. That's creep, and the exact same thing happens to a pipe buried underground.
Yeah, this isn't just some wild guess. Engineers have this down to a science. They use these super rigorous standardized lab tests. They'll literally take a piece of the material, put a constant load on it for thousands of hours, and just meticulously measure how it changes. By doing that, they can create a model that reliably predicts how it's going to behave over 50 years.
So okay, we know that materials get weaker over time because of this creep thing. How in the world do you account for that in a design? Well, this is where engineers pull out a special tool that lets them, in a way, see into the future.
All right, let's look at a really common type of CIPP liner, one made with polyester resin. The day it's installed, its short-term strength is pretty impressive. We're talking around 4,500 psi. It's tough, it's rigid, it's good to go.
But then, you fast forward 50 years. The engineering models, the ones that account for creep, they predict its effective strength will be down to just 2,250 psi. That is literally half, a huge drop.
So what just happened? Where did half the pipe's strength go? Did it just disappear? Nope. The crazy thing is, it was accounted for from day one.
It all comes down to something called the creep retention factor, or CRF. Think of it like a safety factor. It's basically a number engineers use to intentionally discount the material's brand new strength to figure out what its realistic long-term strength will be. And for a lot of these standard CIPP liners, the industry default is a really conservative factor of 50%.
Now, losing half your strength sounds pretty bad, I know. But because engineers plan for it from the very beginning, the designs are perfectly safe. But, and this is the really interesting part, the type of material you choose can completely change that number.
And you can see the difference right here. It's pretty stark. A standard liner, you design it assuming it's going to hold on to 50% of its strength. But an advanced liner, one that's reinforced with glass fibers, that can be designed to retain up to 80%. That is a massive jump in long-term performance.
And here are the numbers to prove it. Check out the standard polyester liner. It starts with a stiffness around 250,000 psi, and we assume it'll lose half of that. Okay, but now look at the glass fiber reinforced liner. Whoa! It starts out over 4 times stiffer. We're talking more than 1,000,000 psi, and it's expected to keep around 80% of that. It's just in a totally different league.
And this is backed up by engineering sources. The big takeaway here is that it's not just about how strong a pipe is on day one, it's about how well it holds on to that strength over decades. A well-designed system, one that uses something like glass fibers for reinforcement, it just creeps less, and that means it stays stronger for way, way longer.
So let's wrap this all up. What's the big picture? First, we have this incredible pipe-within-a-pipe tech that fixes our cities without tearing them apart. But the real genius is how engineers can predict the future by accounting for that slow weakening process we call creep. They use that safety number, the creep retention factor, to design for the long haul. And what we've seen is that the single biggest factor in all of this is the material you choose. Using something like glass fibers makes a world of difference.
And that really leaves us with something to think about. As all this hidden infrastructure under our cities keeps getting older, the real challenge isn't just about how we fix it. It's about choosing materials that are smart enough and tough enough to make sure those fixes last for the next 50 years and even longer.